Namaskaram everyone. Welcome back to the new video, and in this video we are going to continue our series of mastering the Unreal. This is the fourth episode where we are going to continue our advanced locomotion implementation. In the last video we implemented the 8 directional movement with strafing included. Now in this one we are going to implement an animation layer interface, which is also widely used industry standard for creating modular reusable animations and logic across multiple blueprints. Now, to illustrate what I just said, let's consider a simple example inspired by Kratos from God of War. So let's just say, for now, the character can just perform locomotion, but that character has three distinct weapon states in which he can do the locomotion, and each of them reflect their unique abilities and mechanics. Now, each of these states has its own blueprint, but duplicating the locomotion logic, such as walking, running, crouching, for all these three would be a very tedious and challenging task to maintain. And it is not just about locomotion, any state that is common. Now, instead, we can create a shared system for common animations like locomotion or death or something else, and then customize only the animation specific to each weapon state. Now, this is exactly what animation layer interface allow us to do. They centralize the shared animation logic while providing the flexibility to plug in unique animations for each state. Now, this makes your animation setup much more modular and efficient because you do not have to implement the same logic multiple times. Given that we have a base animation blueprint for our character at this moment, which includes the core logic, but we will implement an interface for locomotion states and with the layers for aiming and skeleton controls. Now, after this, we will create a base class that will serve as a linked layer animation blueprint for all the weapon carrying states, which will be implementing this locomotion interface. Now, each weapon will have a child animation blueprint inheriting from this base class. This will allow animators to slot the animation and adjust variable per person. So this is just a visual demonstration of how the implementation is going to work out. So let's jump right into the editor. Awesome. So now we are in our game. Let's do the first step, that is to change this ABP underscore thunder or whatever character animation blueprint name you have given. Just change it to base so that it can be utilized by any character blueprint as an animation class. So I'll say underscore base. So just to recap, this has all the logic that we have done so far. Okay, so now let's go ahead and do the second step. That is to first create a new folder. I will name it Locomotion. Okay. Now under this, we will create a animation layer interface and I will name it ALI underscore locomotion layers. This contains the interface. Now you can see it has given me a default shared group with an animation layer. I will just rename it to locomotion underscore idle. Now once you are done with this, we will ungroup it for now and I will save it, compile it. Now let's create the class that will implement this particular interface that we have created. But first of all, we need to make sure that under the blueprints, you select your mesh. The anim class is set to ABP base. Okay. If it is not, then please make it happen. Now we go back to our locomotion folder and we will create an animation blueprint and select the SK mannequin and we will name it ABP underscore locomotion layers base. All right, double click on it, change the previous mesh to schemani. All right, now under the class settings, you will find implemented interfaces drawer. Just press on the add and add the interface. Now as soon as you do that, you will find the locomotion idle animation layer present in the section. Now hit compile. Okay, and this is the first layer that we have. Now we need to implement the idle animation. So like I said before, the idle animation can vary based on the weapon you are carrying. So that means we have to store the idle animation in a variable so that it can be updated based on the triggers or actions or game logics. So what we are going to do is to create a variable. So we'll create a variable, let's say idle. Now this is of type animation sequence, so I will search anim sequence and the object reference of the same. Now this particular class is ready to accept an idle animation. To receive that idle animation, we have to create the classes inherited from this base class such that they will acquire all the animation layers and variables which they can override. Override means they can override the value whenever they are linked. So right now, if you see in the blueprint third person character, the anim class is set to this. Okay. So what we will do is we will create another animation blueprint class, which is nothing but the unarmed state. So I will select in the parent, I'll choose the ABP underscore locomotion layer space. I will select okay. And I will name it ABP. Oops, rename ABP underscore unarmed layers. Okay. So as we all know, when our character spawns in the world, it will be in the unarmed state. So we are considering that scenario only for now in this video. So just double click on it. Under the class settings, you will find that ALI locomotion layers is already present under the inherited interfaces. Okay, so whenever you inherit a class from a base class, it acquires everything from there. Now if you will see in the class defaults under the okay, also make sure you compile it so that you can see the changes over there. Now you see under the details you have the variable available. Now what you can do is you can select the animation which is the unarmed animation. So I will say mm underscore unarmed idle ready. So now I will hit compile here. So now when this animation class will be linked, this value will be placed in this idle animation variable. Okay, so to do that, what we are going to do is to bring out a node here and we'll search for link anim class layers. Okay, so select this and I'll select the unarmed state. Again, the reason I selected unarmed is because our character, when it gets spawned in the world, it will be in unarmed state. So event begin plays the event that will be triggered when the character enters in the world. Once you are done, save it. Now we need to implement the idle animation layer functionality in the locomotion layers. So to do that, we are going to add a sequence player, right? Once you do that, connect it with this. Now this sequence player is static, which means it can play a specific animation that you are going to provide here. But we want to provide this variable because it has to be dynamic. So to make it dynamic, we can change this to dynamic from here. To change the animation, we have to bind a function with this on update so that whenever a logic triggers, the animation can be changed. So to do that, let's create a binding and let's name it to update idle anim. Okay, once you are done with this, you can extend it. Now it is accepting two input parameters, context and node, that we are going to receive from the sequence player. So the node has to be converted into a sequence player so that we can input the animation sequence from the variable. So to do that, we will search for convert to sequence player, select this pure function under the sequences. Once you are done with this, what you can do is, now the conversion might fail, so bring out a branch node. Now if this branch node is successful, then we will set the sequence with inertial blending. Now select the sequence player, not the sequence evaluator. So do check the description if you get confused. So select it, connect it with this node. Now you can set whatever sequence you want to set in the sequence player. So to do that, we are going to bring this idle here and connect it with this. And we also need the sequence player, so we are going to connect this and this context with this. Okay, let me beautify it. Now let's save it, hit compile. I can see it is working fine now. So I think that's pretty much it. Now I think we can run our character. If you see, it is playing the idle animation. Now let's tweak certain stuff to understand how this thing is integrated. The implementation of the locomotion idle is done by this abp underscore locomotion layers, which is also available under the unarmed layers. It is just not visible, but it is there. So we should now depend on this layer instead of this sequence under the abp base. So we will delete it, and to add that animation layer here, we have to implement that interface here as well. So search for this. Now we have this, connect it here. Now you can see under the locomotion idle, we have connected this layer. Now this layer has no implementation. You can double click on it and you see I haven't implemented the idle animation for this abp base. So it's not going to play anything if it doesn't get any implementation. So let's understand that how it is happening. Okay, so I made a mistake here. That sequence player is not supposed to be present in the animation graph. Instead, it is supposed to be present in this layer. So we will connect this layer with this. Now hit compile, play again. Now you can see our idle animation is playing. Now let's understand by tweaking some values if it's working the way it is expected. So you can see right now the idle animation layer implementation is coming from this unarmed layer. So now if you will go to ABP locomotion layers and you unlink it and compile it again and play it, you will see it is in static pose, right? So I will connect to this. Another thing that we wanted to check is that the link anim class layers. So if you unlink it and compile and play it, you still see it's in static pose. The reason is ABP base was relying on this locomotion idle implementation, but when we check the locomotion idle, it has no implementation. And since we detached this node, this implementation was not overridden by ABP locomotion layers. So we connect it again and we compile it and we play. You see idle animation is playing. So this is how you implement the animation layer interfaces. All right, I would like to end this video here because the sole purpose of this video was just to demonstrate how to implement animation layer interface and how does it provide the modularity in terms of code, logic, and the animations. Do let me know if you have any questions regarding the implementations or any doubts, and please do subscribe to the channel, like it, share it with your friends, and let me know if you have any suggestions. So see you in the next video. Bye bye.